So this video is just going over a couple examples of quadratic inequalities for our quiz on Monday and absolute value inequalities. So quadratic inequalities are kind of in this form right here, where we have ax squared plus bx plus c is greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0. And what you want to do with these is you want to move all the terms to one side, have 0 on the other side, if it doesn't look like the ones I just highlighted in green. You want to simplify and end up factoring this. Then you want to find the roots, or basically the solutions that would make each of your parentheses equal to 0. Those are going to be your boundary points. And that's going to divide your number line into 3 separate regions, okay? And then here they say test each region using the inequality. We're going to use where I draw a parabola to figure out where's above, below, or at 0, okay? So they give this as an example here, okay? They have x squared is greater than x plus 2. They ended up subtracting the x and subtracting the 2 to get it to be this. They ended up factoring it. X minus 2, x plus 1 is greater than 0. And since we ended up with that giving us a 2 and a -1, this is what's going to separate this into 3 sections that you notice here, section 1, section 2, section 3. Now, since this is strictly greater than, that means you're going to have an open circle at -1 and an open circle at 2. And we need to decide if we're shading in between in where they labeled it Roman numeral 2, or outside where they have Roman numeral 1 and 3. Now, they're testing a point, okay? They're putting in a number that's in section 1, section 2, section 3 to see what makes it true, what makes it false. I am going to think of this as a parabola, right? This is a parabola. And I want to know where it's greater than 0, which basically means where it's above the x-axis. So when I'm doing this, the -1 and 2, that would be on the x-axis. So this is a positive or open up parabola. So here, as I'm drawing, let me draw it a little thicker. This is above, 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 or greater than 0. I'm at 0. Don't want it to be at 0. I want it, and then this is below 0, below 0, below 0, at 0, above 0. I want it greater. I want it above. So again, as I'm doing this, I am above 0, at 0. Below 0, at 0, above 0. So I'm actually going to want it to be going in section 1 and section 3. Okay, so you'll see that they tested a number -2, which is in section 1, 0, which is in section 2, and 3, which is in section 3, to see true, false, true. And you see they got the same result that I did. So you could go through and choose a number in each of the 3 sections, determine whether it's true or false in the original inequality, and then you shade where it's true. Or you can think about the points that we find as our boundary points, as those are x-intercepts. Those would be on the x-axis. So if I draw my parabola through it, okay, so that's the yellow part I drew, which I don't really need. I can take that away. I want to see where's it above, where's it at 0, where's it below 0. If I want greater, I want it above 0. Okay. If I want less than, I want it below 0. And if it has to equal 0, then those would be solid dots. Okay. Now, sometimes they may not be in the nice form, and so you might have to work them out. So here's an example where they actually worked out this perfect square trinomial. Okay, here's what it would be when you work out that perfect square trinomial. They also had a perfect square trinomial on this side, okay, with a 2 in front of it. Actually, no, this one wasn't a perfect square trinomial. I apologize. That's not a square on the outside. We're just going to distribute that 2, so they distributed that 2 here. Then what you'll notice they did was they got everything on one side, 0 on the other side. I myself, and they got rid of that negative because we don't want it to be negative, okay? So we want to get rid of that negative. So they divided by negative. What I probably would have done in this situation instead is I probably wouldn't have taken stuff to the left-hand side. I would have taken stuff to the right-hand side. So I would have kept my 2x squared, my plus 14, and I would have subtracted my x squared from both sides, which would have given me a positive x squared. I would have subtracted 6x, which would have given me a negative 6x. I would have subtracted 9 from my 14, which would have given me a plus 5, and this is 0, okay? And when I'm reading this, I want 0 bigger than my graph. So really, I want to be under, okay? So I want 0 greater than my graph. I want 0 to be greater than or equal to my graph, okay? So when they factored it, they got as their factors x minus 1, x minus 5. They solved that and ended up with x equal 1, x equal 5. So they're going to have those be open, not open circles, sorry, closed circles because of the equal part of this inequality. Okay. And then they're going to be, again, closed circles. So let me draw closed circles. So a closed circle here, a closed circle here, and I need to decide where to shade. This is a positive parabola. So I'm going to draw my parabola. I want 0 to be bigger than my graph. So that means I want it to be, my graph to be below 0. So this is above, not what I want. This is at 0, which is okay because I want it at 0. That's why it's a closed dot. Below, which is what I want. At 0, and then above is what I don't want. So I wanted it to be greater. I wanted 0 to be greater than my graph. Okay. So where's 0 greater than my graph? In between. 0 is greater because my graph is below 0. And you see they tested points. They tested a 0, a 2, and a 6, which is in each of the 3 sections. And they ended up with the same answer as me. Okay, so I'm going to try one of these. And in both of, so just to make sure we also understand how to write these answers. So in the first one, where I have 2 separate pieces, I need to define each of the pieces. So they wrote their answers down at the bottom, but let me just show us why that's so. So when you have 2 separate pieces, and right here, this is where they wrote it, okay? But when you have 2 separate pieces, you're going to define each of them. So this first piece here is x. I would always start with my x on the left-hand side when I'm trying to define these separate pieces. Less than -1, and then you need the word or. And then the second piece here is x is greater than 2. And you see that's what they had down there. On ones where you have in between like this, okay? Let me just move it like this. So we have in between. When it's in between, what you want to do is you want to start with the smaller number. So that's 1. And it's going to be less than or equal to, depending on if it's closed or open circles. This is closed circle, so less than or equal to x. And then it's still less than or equal to 5. Start with the smaller of the 2 numbers, and then both inequalities will be less than or equal to. And you see that's what they had right down here. Okay, so now let me just try one of these. So let's say I try one like number 16 here. okay, like number 16. So what I'm going to do is let me first just write it 2x squared less than or equal to 5x minus 2. That's the one I'm going to solve. I want to get 0 on one side, everything else on the other side. And so I'm going to have a positive 2x squared. I'm going to minus 5x. I'm going to add 2 less than or equal to 0. And then I am going to do a box to diamond. I'm going to do the box over here on this side just to space things out. So I'm going to do the box over here and the diamond. So I'm going to have a 2x squared and a 2. So that's going to be a positive 4x squared, but it has to add to a negative 5x. So that's going to be a negative 4x and a negative x. So negative 4x, negative x. Okay. So then when I try to find the outside of that, I'd have 2x here, x here. This will be a minus 1. This will be a minus 2. So then I have 2x minus 1, x minus 2, less than or equal to 0. So I really want to think about it as when it equals 0, so find my solutions. So for this, when I set 2x minus 1 equal to 0, I'm going to get a positive 1/2. When I set this equal to 0, I get 2. So on my number line, I'm going to have 1/2 and 2. And if I look back at the original problem here, once I got it isolated, it is my graph, my x squared, 2x squared minus 5x plus 2 has to be less than or equal to 0. So because of the equal, that means I am going to have a solid dot here and a solid dot here. And then I could either test a number from each of the 3 sections or think of it as a parabola, which it is. And I want where my parabola, because that's the 2x squared minus 5x plus 2 part, is less than or equal to 0. Okay. So here it's greater than 0. Here it's at 0 when I'm actually at the 1/2. Less than 0. At 0. Greater than 0. So I want where it is less than 0. So where that is going to be in between, whoops, don't want it in yellow, in between this dot and this dot, like this. And so my answer is going to be 1/2 is less than or equal to x, which is less than or equal to 2. And that will be my answer. Now I'm going to do one where I do an absolute value example. So let me get one of those up. So I'm going to just jump into an example here. Okay. I'll do 2 examples here. So let me first just do kind of our basic one here where the absolute value is already isolated. So I'm looking at number 1 here. Okay, number 1. And you always want your absolute value isolated, and it is isolated. Then what I'm going to do is I really am going to think of this as a equation. So I'm going to think of it as absolute value of negative 8a minus 3 equals 11. And I'm going to write my 2 equations. So one equation is going to be negative 8a minus 3 equals 11. And my second equation is going to be negative 8a minus 3 equals a negative 11. And I'm going to solve each of those. So the first one, I'm going to add 3 to both sides and get a 14. Then I am going to divide both sides by a negative 8. So I get a negative 14 over 8, which is reducible by 2 to a negative 7 fourths. On number 2, I'm going to add 3 to both sides. So when I add 3 to both sides, I get a negative 8. I'm going to divide by negative 8, so I get a 1. So I have at negative 7 fourths. And let me just change that so I can kind of figure out where it is on the graph. So negative 7 divided by 4. 4 goes into -7. So normally I wouldn't have those numbers there, so you could just put it wherever, but since there's a number line there, let me just calculate this real quick just to get a sense of where it is. So 7 divided by 4 is 1.75. So it's really a -1.75 is where I am. Okay. So I am going to have, let me just do this part in orange. Okay. A point at -1.75, which let's say is about here. And then the other one is at a +1. And these are, sorry, open circles because this inequality is strictly greater than. So I'm going to have an open circle at -1.75 and an open circle at 1. And again, this is split into 3 sections. And I need to decide where to shade. And I could test a number from each of the 3 points, or I can think of this as an absolute value. And I'm not thinking of this as the x-axis. I'm thinking about this basically as the height of y equals 11. This is where 11 is. So these 2 values are at 11. So if I think about my absolute value, which is a v, as I'm drawing right now, this is greater than 11. Once I touch that line, I'm at 11, below 11, still below, at 11, above 11. I want it greater than 11. So again, this is greater than 11, at 11, less than 11, still less than 11, at 11, greater than 11, okay? Let me draw the V kind of more like a V instead of, I don't know what I was drawing there. So my shading is going to be outside of this, And again, I just use that absolute value just to help me figure out where to shade without testing all the values. And I have 2 pieces of graph. So the first piece is going to be x is less than or equal to, not equal to, sorry, strictly less than, -7 fourths or -1.5. Or, and the second piece is x is greater than 1. That would be my solution. Then I'm going to do one where I have a couple steps maybe I need to do first. So I'm going to try one like, let's try number 4 here. Okay. So in this case, I first need to get this absolute value isolated first before I do anything, even before I look at that inequality, because it could change depending if I divide by a negative. In this case, looking at it, I'm not going to divide by a negative, but it could happen on a problem, so you just want to wait. So let me just I'm just going to do some of this math up here. Okay, 4, absolute value of 6 minus 2a, absolute value plus 8 less than or equal to 24. So I'm going to minus 8 from both sides. So I'm going to have 4 absolute value of 6 minus 2a less than or equal to, and when I subtract 8, I'm going to get a 16. Then I'm going to divide by 4. So absolute value of 6 minus 2a. And when I divide by 4 still, I end up with a less than or equal to 4. So now I'm going to write my 2 equations. 6 minus 2a equal 4, and 6 minus 2a equals a -4. So I'm going to minus 6 on this one and get a -2, divide by -2 and get a 1. The other one, I'm going to minus 6 from both sides and get a -10. I'm going to divide by -2 and I get a 5. So these are going to be my boundary points. And I look to where I have it isolated over here. Okay, this is where I have it isolated. And what I'm going to focus on is the inequality here. I want it less than or equal to. So the or equal to part means I'm going to have solid circles. Okay. So I'm going to have a solid dot at 1, a solid dot at 5, and either I'm going to shade in between or I'm going to shade out. So if I look at that green highlight here, this is saying that I want my absolute value. Where is it less than or equal to 4? And this line is where it is equal to 4. That's where y is 4. I want it to be less than or equal to 4. So for this one, if I'm drawing my absolute value, which is a V, okay, I'm starting here. I'm thinking of this. This is above the line. So this is above where it is 4, at 4, below 4, still below 4, at 4, above 4. And I'm talking about a height of 4. Okay, because that line represented a height of 4 because the 1 and the 5 were where it was 4. Okay. And so again, I want it less than or equal to, so that means I'm going to shade in between. That's where my graph's going to be. And again, this absolute value was just there to help me figure out where to shade. And so my final answer, this is the in-between one. So start with the smaller of the two numbers, 1 less than or equal to, because of the solid dot, x less than or equal to, and actually this is an A, sorry, it's an A, whatever letter it is, less than or equal to, again, because it's a solid dot, 5. That is your answer. So hopefully this helps study or review for our quiz on Monday.